The chain rule notations. There are many notations for the chain rule. One is dy over dx is equal to dy over du times du over dx. For the power rule in chain rule, we have, to find the derivative of u to the power n with respect to x, is equal to n times u to the power n minus 1 times du over dx. For function notation, we have the function of x or f of x to the power n is equal to n times f of x to the power n minus 1 times the first derivative of f of x or f prime of x. For the composite function notation, we have, to find the derivative of f of g of x, is equal to the first derivative of f of g of x or f prime of g of x times the first derivative of g or g prime of x. Whatever the notation you use in finding the derivative using the chain rule, there is only one meaning to these, and that is finding the derivative of the outer function times the derivative of the inner function. Example: find the derivative of quantity 2x cubed plus 4 to the power of 5. To solve this, first we are going to differentiate all that is raised to the power 5. In order not to change anything inside the parentheses, we are going to leave it blank, and by power rule, we have 5 times quantity blank raised to the power 5 minus 1, which is equal to 4. Then we can write back 2x cubed plus 4 for the blank inside the parentheses. This is differentiating the outer function. Now let's differentiate the inner function, which is 2x cubed plus 4, and by power rule, this is equal to 3 times 2x squared since the derivative of 4 is 0. To simplify this, let's multiply all that is outside the parentheses, so 5 times 3 times 2x squared, which is equal 30x squared, so the final answer is 30x squared times quantity 2x cubed plus 4 to the power of 4. We just first need to know that quantity 2x cubed plus 4 to the power of 5 is the outer function, while 2x cubed plus 4 is the inner function. To differentiate using the chain rule, we just need to know what is the outer function and the inner function.